Hello and welcome everyone. Thank you for joining us here. My name is Anouk. I'm the Program and Content Manager at Hello Tomorrow. And it's truly a pleasure to have you here for what is actually one of the very first webinar held on the core by Hello Tomorrow. So a heartfelt welcome to everyone. Most of you should be familiar with our global summit that is held every year in Paris. And this year the summit will happen the 2nd and on the 3rd of December in Paris in physical form, so finger crossed. And the summit is really the time of the year where our deep tech community is gathering and sharing all kinds of knowledge and advice, and where the finalists of our global challenge are pitching. So really, truly where the magic happens. And we really wanted to keep that energy, keep that momentum going throughout the year. And so we created the core. Welcome on the core. The core is where all things deep tech are happening. So it's both a lead up and a follow up to the Global Summit. It's meant to bring you insights, connections, and knowledge, and make sure that the deep tech community has a good place to interact regularly throughout the year. So the way it works, it's quite easy. You can register to the newsletter if you haven't done so yet, and you will receive exclusive info on our trends, on our webinars, such as this one, on our reports, as well as great opportunities from our partners. So since it's quite new, I must highlight this. You're more than welcome to give us feedback in order to make it more valuable for you. So I'm assuming that if you're here, you have read or you are at least interested in one of our latest reports, Nature CoDesign. And without further ado, I have the pleasure of welcoming on stage Nicolas Goldel, who's one of the co-author of our report. Nico, the mic is yours.
Thank you very much, Anouk, and hello everyone, and a warm welcome also from my side. It's a great pleasure to take the next 20 to 25 minutes to reshare with you the key insights of the Nature CoDesign report we recently published, and then afterwards open up the floor and take all your questions and then engage into a discussion with you. And you have the chance already throughout the whole presentation to write your questions in the chat, and I will do my best to answer them at the end of the presentation. And I don't want to give you a fully fledged intro to Hello Tomorrow, but I still want to tell you how it came about that we wrote this report. So Hello Tomorrow is all about building a collaborative deep tech ecosystem. And for this, we bring all kinds of stakeholders together, namely investors, corporates, and deep tech startups. And to bring those deep tech startups into our network, we do not shy away from any effort. And we really go out and source and scout them worldwide to bring them in our network. And by animating these networks and curating the knowledge we receive from them, we analyze trends, and we have a deep insight into the innovation landscape and through the deep tech innovation landscape. And over the last years, we have seen more and more startups that emerge that are developing solutions that originate in the area of Nature CoDesign. And that's why we wanted to show that to you and share this trend more widely. And that's why we wrote this report in collaboration with the Boston Consulting Group. And you've seen now here on the left-hand side a lot of deep tech on the screen. And just to bring everybody at the very beginning on the same page, I just want to share with you what we at Hello Tomorrow understand under deep tech. So for us, it's more than just a technology. It's actually an innovation approach that uses emerging technologies that are rooted in science and advanced engineering to tackle really societal issues. And how those technologies are used provide actually the power to create new markets and disrupt industries. And with this, I want to jump right into the content, and I believe that the man on the right-hand side of your screen doesn't need much of an introduction. He is seen as a true visionary, and he proved his talent one more time in 2011, where Steve Jobs said, and I quote, "I think the biggest innovations of the 21st century will be at the intersection of biology and technology. A new era is beginning." And why while he may fail to grasp the whole extent of the revolution we are seeing, he got the general direction right. So we will change the innovation equation from bits only to bits and atoms. And this revolutionary shift we call Nature CoDesign. So Nature CoDesign for us is where biology, material science, and nanotechnology meet to leverage nature's design principles and manufacturing capabilities. And it represents a tremendous business opportunity and the chance for us as society to transform to a sustainable future. And on the right-hand side, you see what I mean with changing the innovation equation. So I think you would agree that most of the recent innovations originate either in the field of cognition or senses and motion. So either in computation or in robotics. And by now, or through Nature CoDesign, we add a whole new field, like matter and energy, so what we call Nature CoDesign. And it's not only that we add one field where innovations will originate from, but we also triple the interfaces between the different fields. So we had just one interface between cognition and senses and motion. Now we will have three. And those areas of particular interest, because where fields overlap, there where we see convergence of technology, often stunning innovations come up. And one of those like paradigm shift innovations that I want to focus today on is actually the new era of production that we will enter. So what do I mean? Here on the upper side or upper half of your screen, you actually see how more or less our current economy works. And surprisingly or not surprisingly, it's still based largely on the principles of the first and second industrial revolution, meaning that we extract fossil fuels, burn them to generate energy, that then powers our refineries where we use natural resources that we have mined from our planet to eventually produce new materials, food, refined chemicals. And by doing this, we are emitting large amounts of CO2 into the atmosphere and waste a lot of heat. Now, with Nature CoDesign, we enter a more of what I would call a regenerative economic order. So we will use actually CO2 or sugar as feedstock, feed it to microbes whom we have engineered to produce for us new materials, food, refined chemicals. And what's the actual clue about it? So we will transition from brute force to smart design. So instead of actually mining raw materials and then using large amounts of energy to break them back down into building blocks and refine them, we will, or smart design or design itself becomes actually the dominant aspect of this new era. So let's look at the two graphs that you see here on your screen. On the left-hand side is the one of depicting our current practices. So again, we have the natural elements, we let nature do the first step, through biosynthesis build up the raw material. Then with large amounts of energy, we break them down into building blocks just to build them up again, to manufacture them into final products. Now on the right-hand side is the Nature CoDesign way of manufacturing. So we will start with natural elements, but we will go straight all the way to the final product. Or maybe we have a little layover at the building block stage to then continue to the final product. But what is important here is that we basically have just one transformation. So we go all the way up continuously, while the previous, so basically our current economy based on the first and second industrial revolution has three transformations. So first, nature builds up. Then we break it down to the building blocks and we build up again. And all of these transformation steps require lots of energy. And so you can see that Nature CoDesign just inherently will be energy efficient. Why is that important? Well, I hope that most of you are aware that we have entered the anthropocene. This geochronology epoch is characterized by the fact that humans have become the single biggest driver of planetary change, affecting our own life support system, the Earth. And just a few numbers to back that up. So as of now, as of this month, we have reached 416 CO2 particles per million in the atmosphere. That is almost a 50% increase to pre-industrial levels. We are witnessing the 6th mass extinction. Just this time, it's the first mass extinction that is caused by another species, us humans. And we are actually not witnessing it, we are conducting this mass extinction. Then we have about 15 really important large-scale Earth systems that are essential for our planet and for having the seasons and the climate that we have today, that were essential for us to start agriculture and farming. And 9 of those 15 are on the move and are at the risk of tipping over. And the number that you're probably most familiar with is the average global temperature rise, currently at 1.2 degrees compared to pre-industrial levels. And it's further increasing, and we should limit it absolutely at 2 degrees, not because it's written in the Paris Climate Agreement, but because the last 3 million years, there was never ever an average global temperature above 2 degrees. So we don't want to play with our life support system. Let's try to stick to this maximum of 2 degrees. And actually, researchers at the Stockholm Resilience Center in Sweden have mapped our effects, so like basically how we affect the planet on 9 dimensions. And I want you to focus on climate change on the top, the biogeochemical flows on the bottom, divided in nitrogen and phosphorus, the land system change, and the biosphere integrity. On those dimensions, we are currently stressing the planet beyond its means, beyond its limits, and we need to get back into the green sphere in the middle. That is the safe and just space for humanity to thrive. The good news is that Nature CoDesign will enable us to get there. So let's look at this other illustration. We are currently at a crossroads. Our Earth is at a crossroads. If we continue with current practices, we will degrade our biosphere, we will cross those planetary boundaries of all the dimensions, and Earth will enter into a vicious cycle. Earth will become a hothouse that is, in part, not inhabitable anymore by human beings. But the good news is that science says that there is still a window of opportunity to change. We have to adopt an Earth system stewardship to bring back, basically to stress less our planet, to come back into the safe and just space for humanity that you've seen on the previous slide. And Nature CoDesign will be key to achieve this stable Earth position again. And so why is Nature CoDesign inherently sustainable? So you remember the graph that I showed you, so it's energy efficient, but there's more to it. So we will actually go from waste to resource, meaning that we will create a universal material ecosystem by re- and upcycling all materials. The waste of one process will become the resource for another one. So we will come close to a circular economy. Then we will use nature as manufacturing platforms. So as you've seen, we will obviously still, to a certain extent, use the resources of our planet, but much more than that, we will partner with nature and really use it as manufacturing partner to produce the goods that we want instead of only using its output. And then the third point, as I mentioned, it will allow for energy efficient production. But I said also in the beginning, it's a transformational business opportunity. So according to predictions, Nature CoDesign will disrupt whole value chains, and up to 40% of the global GDP as of today, which equals more than 30 trillion US dollars, will be impacted. And that's across all industries. You see them down on the left-hand side. Starts with food and agriculture, over to energy and utilities, all the way to healthcare. And Nature CoDesign affects those value chains and those industries along 4 intertwined dimensions. First is we will see how it enlarges the option space, how we will create value nets instead of chains, how Nature CoDesign comes with a completely different set of economics, and how it is important to push scientific frontiers and harness scientific knowledge. And please don't forget to write questions into the tab on the right-hand side. I will look at them as soon as I close this presentation. and then hopefully engage with you in a discussion. But let's go along those 4 dimensions and look at the first one. And for this, I want to look through a lens of the agriculture and food industry. So how will we enlarge from the option space in this area? So you know that we are about 8 billion people currently on this planet. And to feed all those 8 billion, we need agriculture and we need nitrogen fertilizer. Without nitrogen fertilizer to boost the growth of crops, estimates say that around 4 billion people would starve. And one of the central pillars of producing nitrogen fertilizer is actually the Haber-Bosch synthesis. And that is a century-old chemical process. And incredibly enough, it takes 1 to 2% of the global energy consumption. So each year, 2% of the global energy consumption are used just to produce fertilizer. And the worst thing is that 50% of it are actually not taken up by the plant, but they just run off, causing environmental pollution, causing pollution of our water and soil systems. And there's a high barrier to entry for innovation because the typical cost of such a facility is almost $3 billion US. But now we have Nature CoDesign, and the company that is at the bottom left that I want to introduce to you is Joint Bio. And they actually engineer microbes in that way that they, you could say, pre-digest nitrogen for the plant. So they make nitrogen in the soil more accessible for the plant and thus reduce the need for putting so much nitrogen fertilizer out on our fields. Secondly, Nature CoDesign is not only like improving existing processes like nitrogen fertilization, but it also gives rise to new ways of producing food. Let's focus on the bottom part of the screen. So there you see Solar Foods as an example of many, many companies that we see here at Hello Tomorrow that engage into precision fermentation to provide protein sustainable. So they use microbes, grow them in a biofermenter, and let them secrete proteins that then can be used as nutrition. And this technique requires 5 times less energy, 10 times less water and feedstock, as well as 100 times less land if you compare it to proteins sourced from cows. And it's clear, I think, it's very evident from those numbers that it contributes to a reduced resource using, as well as if we eliminate the need for at least big-scale livestock farming, we will also reduce the need for hormones or antibiotics in animal farming. And another company that deserves mention is Just Eat on the upper right-hand side of your screen, because they have just recently, as first company worldwide, received approval from authorities to sell publicly their lab-cultured meat. So this meat originates from the laboratory and starts off with a single animal cell that then is using lab techniques reproduced, and so whole cut meat can be produced from using that technique. And as well, the Just Eat works on plant-based dairy products, so replacing basically the egg with proteins coming from plants. And with this, you can see that by enlarging the option space, that we can conduct agriculture and animal farming and feed the 8 billion people on our planet very differently than before. The second dimension I want to look at with you is the one of creating value nets, so transitioning from value chains to nets. And for this, I want you to look at one of my personally favorite companies that have applied last year to the Hello Tomorrow Global Challenge, Swedish Algae Factory. You see here on the left-hand side of the screen a picture of an algae, of a diatom within silica shell. And you look at the scale bar, we are here talking about an element or like a life form that is no bigger than 5 or 10 micrometers. And they produce, or basically they grow these algae to then harvest the silica shell from them for solar panel as well as for personal care products, because this algae has developed over millions or maybe even a billion years now and has been optimized through evolution to trap light and filter out UVA and UVB, which is very useful, obviously, if you think about sun blockers or about solar panels, where it's all about trapping light. But more importantly, or what I want to focus you on, is that how do you grow algae? The only thing you need is water, minerals, and CO2. And that's exactly what I mean with that we create value nets. So waste in one value chain. So our current industries, emitting a lot of CO2. That's actually no longer a waste. It will become a resource for another process. And that leads to the fact that chains will be basically interconnected and transformed into value nets through waste that becomes feedstock. The third dimension I want to look at is redefining the economics. So let's look at the economics that come with Nature CoDesign. And for this, I want to introduce you another stunning startup from our community, Hue Biosciences. So Hue Biosciences has developed a process where they use microbes to biofabricate the indigo dye. So instead of using chemical synthesis, a lot of polluting agents, they have engineered microbes that are fed with sugar to produce an indigo precursor that then undergoes a last processing step with an enzyme to result in the actually dye that you use for example, for the famous blue jeans. And when we look now here at Nature CoDesign's tool set and how it allows us to precisely modify things, its selectivity and energy efficiency, this has tremendous impact also on the economics of manufacturing. So the first thing is that in traditional manufacturing as we do it today, usually CapEx is all about your machineries as well as the big industrial plant to produce your product. This will change. Your most value bringing asset will actually become the organisms and the DNA code that encodes the organism's features. Then in current industry practices have an intrinsic need for scale. The bigger, the better. This is not true anymore for Nature CoDesign, because we are dealing here often with living organisms. It behaves more like an S-curve that will say that beyond a certain point in scale, there will be no further improvement. So it's all about hitting that sweet spot where you can maximize your profitability, but it doesn't necessarily come with scale. And then the third part that is, important for all new incumbents into a market is riding the experience curve and create the right value strategy for its own product. So meaning for Hue Biosciences here, it is probably important because this new technology can't compete only on cost with current industries that have been established for 20, 30, 50 years. So they have to have added value, which is clearly there. It's the sustainability aspect of their solution. But still, people will probably need to pay a premium for this. So they have to target, obviously, not the market of the $10, the 10 euro jeans, but more the high-end linen industry where jeans cost 200, 400, 600 euros or US dollars, because they're paying $1 or $2 more for this process compared to the standard chemical synthesis won't chase away the customers. While when you do that for a 10 euro or $10 jeans, that equals almost a 20% increase that maybe the customer at the end is not willing to pay. So choose your value strategically or your strategy strategically, so that it allows you to sell, and with each sell and each manufacturing cycle you gain an experience, and you can drive down the costs to then eventually end up also in the mass market. And then the very last aspect I want to emphasize on here is how Nature CoDesign pushes scientific frontiers. And for this, I want to introduce Kibotics to you. Kibotics has developed an AI and robotics-enabled self-driven lab. So basically, it's an AI that rules robotic apparatus and synthesizes many different small molecules, because the chemical space is vast. So we have 10 to the 60 opportunities of small molecules, but only 70 million of them have been discovered and synthesized so far. And Robotics is doing that in an optimized fashion, trying to explore this vast space and coming up with new chemistries and materials. And that is really important because there is a lot to learn still for us. So there's actually a lot we don't know. So science must continue to advance and to pave the way for innovations such as the ones that you have seen also before. And just to illustrate this, so I was talking at the bottom of the screen about the small molecules. We know 70 million, but there's 10 to the 60, so trillions of trillions of trillions of trillions that we don't know. We have probably about 10 billion species here on Earth if we take into account all microbes. But we have less than 100,000 genes or genomes sequenced, and most of them just partially. And also even eukaryotic species, we know 20%, but we don't know 80%. So we need to expand our R&D capacities to be able to really harness the power of scientific advances further. And with this, I come to the end, more or less the end of my little input here. But I still want to say a word about the potential consequences of nature co-design. So there's, first of all, societal considerations, so things that affect me and you, because I haven't been going into detail about engineering biology at scale, but it is linked to a high degree of uncertainty and ambiguity. How can we make sure that this technology is used in a way that will only benefit humanity and not let us regret at one point the development of it? So I think we need to have these discussions about ethical and regulatory frameworks proactively for nature co-design. That is true for all new technologies, but I think particularly for the nature co-design field. And then look at the political or the geopolitical side of things that may also turn upside down here, because if you think about what you heard now, maybe countries that are rich currently in raw materials, so mainly in oil, will lose their position on the world stage to countries that, for example, are rich in biological diversity, because there's so much unknown biology out there, and there's so many molecules still hidden that will have tremendous benefits for humanity. So maybe that turns upside down, and countries like Ecuador or Brazil become the new geostrategic key players. And then look at the supply chains by linking input and output. It is very likely that it will result in a more distributed and local supply chain. So also that may render us then more resilient and safe from geopolitical issues and conflicts. And I hope I could convince you, and I want to use the words of Al Gore here, that, and I quote, "We believe that we are in the early stages of a sustainability revolution, one that will be larger than the Industrial Revolution with the speed of the digital revolution. And we believe it's the biggest investing opportunity in the history of the world and the biggest business opportunity in the history of the world." And with this, I want to give a special mention and a heartfelt thank you to BCG, and particularly to Massimo Portincaso, who has been a partner at BCG at the time and a real driving force of this project, together with his team, and particularly Arno and Sylvia. And I'm happy to take any questions now. I couldn't see if there are any, as I'm here on my PowerPoint full screen. But in case also that you need to go, or later on, if you read the report, questions come up, please don't hesitate to reach out to me. My email address is here, or also connect on LinkedIn. And with this, thank you very much for your attention, and happy to engage in discussions.
Thank you very much, Nico. It was really, really interesting, and there's already a lot of questions in the question tab. Just so that to leave you a little bit of breath, just to tell everyone that if you are interested in our reports and in our insights, I will also put in the chat the link direct to our deep tech resource on our website, where you can find this report, obviously, but also some others that we have been doing. So I'm just going to start with some of the questions that have been asked in the question tab. And sure. The first one is it's an interesting one. It's maybe the shortest, so it's an interesting one. Why the term, it's from Max, why the new term Nature CoDesign instead of the established and perhaps hype terms such as synthetic biology?
Yeah, hi Max, great question. So what we wanted to emphasize on is that it is not only based on biology, but that it goes further and also really includes parts of material science. I haven't been showing too many detailed examples here, but that it goes further than just biology. And as you may know, also synthetic biology is a double-edged sword just from a communication point of view. It has been in the past, there was certain backlash against, for example, genetically modified organisms. And we would just like to establish Nature CoDesign from a neutral starting point. And then let's discuss together about if that is good or bad. But we wanted to avoid this trap and basically make people think that this is, first of all, only about synthetic biology, and secondly, only about genetic engineering, which is unfortunately, has a bad connotation.
Thanks. I hope that answers Mike's questions. The next one, it's one from Philip. So I'm reading it so that you have time to think. Natural processes are usually slow, expensive, and not energy effective. On the other hand, reactions of traditional chemistry are quick, highly efficient, and cheap. So what shall be a good balance for companies between natural and traditional processes?
I mean, I agree that there is the necessity to have both, probably. So it's not that Nature CoDesign will be able to replace everything. What is a good balance? I think that depends on the individual use case or value chain you look at. But I want to emphasize that there is, the sustainability angle is a real issue, and we may underestimate it still because we have a hard time as humans to think long term about 20, 30, 40, 50 years. But I think that we should, as much as possible, switch to nature-based solutions. And through genetic engineering, I think we can overcome some of these obstacles that you mentioned, that they are rather slow, although I wouldn't agree that actually I think enzymes have, for example, like some of them are super high turnover, and that on average, I think compared with chemical processes, that nature offers often very energy efficient solutions. So I think with the sustainability angle, I would slightly favor the Nature CoDesign approach. But it's true, it needs, at least for the transition phase, still the chemistry as well.
Thank you. Another question from Jason that was quite upvoted as well. Regarding joint bio that you mentioned, what is the impact of the introduction of a new species to the pre-existing microbiome? Have any studies been done?
Yeah.
It's a question that I've seen already in our summit. It's a question that's also regularly asked.
Yeah, obviously, Jason, this is a very good question, and I'm not saying that. I mean, it comes with certain dangers because I am personally not aware of any studies. I also am not aware of the vehicles of the microbe that they use actually and put out there in the nature, if it's a common one, if it's a complete new species. How will the interaction be with the bio ecosystem, actually, not only the microbiome that is in the soil? Those are all good questions, and I don't say that this is the best solution out there. You could leverage the microbiome maybe itself, as you probably know and also point towards to. But yeah, it needs definitely studies before that can be put out into the nature, and actually it should have long-term studies and not only in one location on Earth, but on several locations to make sure that there is no harm on the long term. Or if you build it genetically in that way that you have a kill switch that you could eliminate just this microbe in case it would escape into the wild and and cause damage.
Thanks, Nico. Another question from Thomas. Can you elaborate further on how Nature CoDesign might affect industrial production and take us further into or beyond the current Industry 4.0 wave?
Yeah, I really believe that we will see more and more small organisms such as microbes being leveraged to work for us and to produce for us. And definitely, I think also the example of the Swedish algae factory, where we actually use microbes to produce not only something of organic origin, but actually something inorganic. This is something I personally look forward to, so that we use microbes and enzymes to manipulate one day also on a customary base the inorganic world. And that's something that we see first signs, very weak signals, but that may in 5 to 10 years from now will be as we see SynBio today.
Thank you, Nicola. There's another question from Claudio, who's thanking you already. And then he's asking, what's the role of military research and utilization in all of this? There are lots of projects regarding advanced materials from agencies such as the Office of Naval Research or Army Research Lab.
Yeah. I mean, when we look back at the waves of innovation, DARPA, so actually the funding organization in the US for military purposes, has driven a lot of current innovations, GPS, generally I think the iPhone is probably to 80 or 90% what's in it is funded through military agencies. So one thing is obviously the funding, and the other thing is the use. And could potentially engineering biology at scale and making it more accessible, so reducing the barriers of entry to this, allow to engineer microbes that are actually harmful to humans and are released purposefully. Yes, definitely. I mean, there is a danger to that. When not saying that I don't think that any army organization is funding that directly, but just like the indirect effects. Technology it always depends on the use of technology, if it's beneficial or harmful. And I wouldn't say that any military funding is per se a bad thing, but obviously it should be transparent. We should know what's going on, what researchers do in their labs, and have this society-wide discussion around the use of technology.
Yeah, this is definitely that discussion that we are fostering with the core and with the Global Summit. So it's a really good question. Thank you. A recent question from Jean-Michel, who's asking, how do you position Nature CoDesign and the biomimicry or bio-inspiration movements, with air quotes?
Yeah. To me, Nature CoDesign goes a bit further because it's not only inspired by nature, but it really works with nature, it partners with nature. So I think the nature mimicry, biomimicry movement is great. And the winglets of the airplanes, for example, are inspired by birds and so on. And it will serve, nature will continue to serve as inspiration for humanity. That is for sure. But I think that Nature CoDesign goes a bit further and not only uses nature as inspiration, but really partners with it.
Cool, thank you. There's a good question by Vittorio, who's saying, one thing I don't understand about Nature CoDesign is how is it possible to animate the DBTL, so design, build, test, learn cycle thanks to nature? How is that possible to build and test something just thanks to nature? That's his question.
Yeah. So yeah, I wouldn't. I mean, I agree. I wouldn't say it. I wouldn't formulate it and phrase it that way. So what the design, build, test, learn cycle does is actually that it allows, let's say, it allows the shift from only fundamental research to fundamental research with client centricity. Because through employing all those different elements like design and prototyping, testing, learning from it, this is actually the cycle that most startups in the digital world have used so far. But now through having the tools like, for example, AI that can analyze biological data, you can also apply it to Nature CoDesign. So it basically just is now also available to deep tech in general, and as a hallmark of successful deep tech companies to really go through the cycle, employ automatization, employ AI to learn from data, and really do it in a user-centric way. And that's what I would say is the big benefit of the DBTL cycle. But it's not that, it's thanks to Nature CoDesign. It's rather thanks to all the technologies that are developed for each stage. So AI for the design, robotics for the automation, that this DBTL cycle now is available. It's affordable even for startups to implement in their businesses and to just run more experiments, do more rapid prototyping, and like this refine the product and really allow to have a shift, to have several iterations through it to become really user-centric and problem-driven. And that's where we see the great strength of the DBTL cycle in.
Thank you very much, Nico. There's another question here that's quite interesting. Is Nature CoDesign 100% sustainable? And then Arvind elaborate a little bit and saying, nature has found some great system designs, but it isn't perfect. So natural evolution is random and sometimes inefficient, while humans can redesign systems. So further up, the question is, how do we measure second, third order effects in Nature CoDesign, or if we over-design certain functionalities?
Oh, yeah, a lot of questions here.
Yes, a lot of questions to unpack. We can take it bit by bit.
So bit by bit. So let's start with, is nature perfectly sustainable? And well, so far, let's say nature has the ability to usually to recycle more or less all its solutions. But again, it's not about just doing what nature has done, but it's actually engineering nature. So also here again, we are not relying on the boundaries that nature has set us. I think we really can design to an application, and the food and agriculture industry is a great example here. So we can really take it further, and we know the design principles, right? We can write and read DNA, so we can basically redesign codes. We don't need to take that what is in nature available. And by going beyond this, we will obviously also maybe create materials that we also don't want to be degradable in nature, right? So there will be parts of it, will be solutions that are not perfectly fitting the universal material ecosystem. But it will set us on the general trajectory will be one that is more sustainable than current industry practices. And with regard to, was it with how to forecast or how to grasp the second and third order consequences?
Yes.
Was that? Okay.
Yeah. How do we measure second and third order effects in Nature CoDesign, or the over-designing part of it?
Yeah. So I think, I mean, first of all, we have to think about it. And there I would like to just share an idea. It's not my own. It's from Owen Gaffney. It's one of the researchers at the Stockholm Resilience Center, who said it needs an anthropocene officer, so somebody that actually can look at the new solutions, at innovations that are out there and really try to assess their impact on Earth or on our society. So I think that's the first thing that needs to be established. And the second thing is, how to measure it. I think there's first processes in place, so life cycle assessments of innovations or of products, where you look in detail at what's the recyclability, what's toxic components, and so on of a product. So this is maybe that's rather first to second layer, and then third layer, really ethical frameworks. It's tough. I think it needs constant dialogue. It needs dialogue across eco chambers. So not only have a dialogue with when you are a scientist, with your scientist colleagues in the innovation community, not only with the innovation community, but really cross-border, really cross eco chambers. So like look at people from very different fields and listen to their opinion and try to learn as well from the past. I mean, looking at the CFCs, like that were responsible for ozone depletion, and we weren't aware of it at the time. And it is a trial and error process, I think. I don't think there is a perfect way of forecasting all second and third order consequences at the very beginning, but we will win already quite a bit if we, as person who puts out the technology, has also an interest in its governance and its use, and not just say, okay, that's the technology here that we develop, and now I don't care anymore. So I think just this mind shift already can help to, hopefully eliminate the worst and most harmful consequences.
We're starting to get closer to the 45-minute mark, so we'll need to wrap up. But there's one last question, and then, of course, as Nico said, you can reach out to him either on LinkedIn or directly through through his Hello Tomorrow email address. So feel free to engage later on. The one last question that I feel we should mention is one from Florian, who is asking: are there limitations linked to scale or up-down fluctuation of demand in such co-production processes?
Yes, so let me say like this. I think Nature CoDesign has an intrinsic advantage here because as we are not building plants for like billions of liters, but we have rather small plants, like for example, those bioreactors featuring, 10 bioreactors with 100,000 liters each. You could imagine that you just swap out the organism for something else. So if the demand is satisfied of one product, and you see a switch in demand, that's actually much easier than in current industry practices, because if we think about something that can be produced by microbes, you could easily swap out the microbe. You may have to change the feedstock for sure, but the infrastructure itself remains the same. So you could actually quite easily have a dynamic production floor where you on demand can produce one or the other chemical or a valuable product.
Brilliant. So thank you very much, Nico. Thank you to everyone who asked questions. I think we need to wrap this up, but I hope that you enjoyed both Nico's presentation and the discussion that we had right after. And we do hope to see you in the future webinar that we will host on the core. And once again, wherever you are in the world, have a lovely day or evening, and we'll see you later then. Have a lovely night.
Thank you, everyone. Bye.
Goodbye.